Chapter 5 Procedures. Before we talk about how to design a procedure, we have to understand what's stack operations. There's a runtime stack manipulated by the operating system. We can use a push operation to add a value to the stack. We can use a pop operation to remove a value from the stack. We are going to see how to reverse a string using push and pop. Stack is like a place of dishes. You put one on top of each other. The first one you put on the stack will be on the bottom of your stack. The last one you put on the stack will be called the stack top. Stack is life structure. The last one you last in first out. So your last one you put on the stack will be removed first. The runtime stack managed by the CPU using two registers. Stack segment SS holding the stack segment's memory address. ESP stack pointer is holding the top values address. That means the first one available on the stack, the top one. A 32-bit push operation can add a value to the stack. Every time when we push a value into a stack, the stack pointer address will decrease by 4 and then copy the value to the location on the stack. So in this picture, we have first value 06 hexadecimal on the stack top, and ESP is holding the address. In the second picture, and we have pushed another value hexadecimal A5 to the stack. So ESP is holding the new one's address. So ESP is a pointer used to hold the top available values address. So this is a growing downward stack. So this stack will grow downward, not grow up. So if we use two more push operations, we can add two more values to this stack. So 01 will be the third push operation, 02 will be the value for the fourth push operations. So this stack grows downward. Usually the stack is supposed to grow up. The pop operation allows us to remove a value from the stack top and copy the value into a variable into a register. Suppose we use a pop right here, and this value will be removed from the stack and copy into a destination. So this is the syntax for push. You can push a register or memory 16 bits or 32 bits or a constant immediate value. Same thing for the pop. But for the pop, you cannot pop a constant value because we are trying to pop the top available value from stack to variable or register. Use push and pop, you can save and restore registered value. We can push ESI, ECX, EBX to the stack. So after we have three push operations, EBX will be on the top of the stack, ESI will be on the bottom of the stack. And we can do something in the middle. We can use ESI, ECX, EBX to do something like a loop or other things. After we finish our task, we can restore these registers values. So we're going to pop, that means copy top value into EBX and copy second top value into ECX and copy the third available one into ESI. So this is called a save and restore. Last one you saved to the stack will be restore the first back to the register. So this is a reverse. Last one is EBX, but the first order also is copied into EBX. We can use the push pop to work with a nested loop, and we have used nested loop previously. In previous version, we have used the variable to hold the outside loops counters value before we get into internal loop. And since we have learned how to use push pop, we can save outside loop counters value to the stack. Then we can set up the internal loop. Then we can use it for control of loop 2. After we finish loop 2, we need to resume the loop counter for L1. So we pop the stack value into ECX. So this is a restore of the ECX value for the outside L1 loop. So push pop always pair together to save and restore. In the book, we have reverse string operation and a program, so we can see the source code in the book. Let's see how to use push pop in the assembly language program. I have used 3 push 3 pop in this program. Before I do push pop, I have copied 10 into EAX, 20 into EB, and 30 into ECX. Then I call dump register's value to verify the register's value. Then I start my 3 push EAX to the stack first, then push EBX, then push ECX. So the stack top value will be ECX, the second top will be EB, the third top value will be EAX. After this, you can put some statements in this location, like you can do other tasks. After you finish your task, you can restore the 3 registers value. So the first one, stack top value is ECX because you push the last one. So you want to restore ECX first, you have to say pop into ECX. And then we restore EBX by pop into EBX, then pop into EAX. Dump register, you can verify the 3 restored values in 3 registers. Let me run the program. Okay, let's check. So I have printed on message first. So my first dump is just to verify my 3 values before I push EA, EB, ECS to save them. So my first dump should be EA10, A is 10 in hexadecimal. Second one, EB has 20, 20 in hexadecimal is 14 H because 1 means 16, 16 plus 4 is 20. My third value is ECX is 30, and ECX is 1E. 1E means 16 plus 14, that's 30. So after I have popped restored my registered value, I dump register again. So I should have the same value as the first dump. So my EA is 10 and the EBS is 14H, that's 20. ECX is 1E, that's 30. So they are right. Let's see how to reverse a string using push pop operations. I have declared my message as a byte. Assembly language programming is fine, end with null 0. In my code segment, my main procedure, I clear screen first. Then I print out the original message, move offset my message into EDX, then call write string. So this is your way to print out a string. Use the library function write string. I print the CRLF. This is a library function to have a blank line or carriage return line feed. Next, I'm going to show you how to reverse a string use stacks. I have two loops, loop 1 and loop 2. In loop 1, I'm going to push each the letter in this my message into the stack. In loop L2, I'm going to pop the letters from stack back into the my message string. So in loop 1, I did a push. Before I do loop 1, I did a setup for L1. I use ESI as loop register and the loop index for my messages. So I put a 0 index into ECI first. Then I move ECX with the size of my message. So this set up the loop counter ECX to be the size of my message. Then I decrease the ECX. The reason I decrease ECX is because I don't want to copy the new character at the end of my message. So start inside the loop 1, I copy my message 0, the first one, into EAX. Here I have used the special move statement move 0 extension x. This allows me to copy 1 byte to 4 bytes, and additional 3 bytes will use 0 in EAX. The reason I use EAX is because push instruction only can push 16 bits or 32 bits memory or register. So after I push one letter into the stack over here, I increase the index ESI by 1 because each of these letters are 1 byte apart. So I increase ESI by 1. Then I loop back to L2 to repeat until ECX becomes 0. So loop L2 will decrease ECX automatically. So as long as I set up the loop counters right, my message, the whole string will be copied into stack. So the last letter in my message is exclamation mark. This will be on the stack top. So in loop L2, I'm going to reverse the string by copying back the stack value into my message. I did a setup also for loop L2. I use ESI as index reset to be 0. Then I reset the loop counter. Then I did ECX. So inside loop 2, I pop EAX. That means copy the top value from stack into EAX. The top one will be exclamation mark. So the exclamation mark will get into EAX first. Actually, it's in AL. Then I copy from AL into my message 0 location. That means the first place. This will copy exclamation mark from AL into my message 0 location. So if I increase ESI by 1 more, that means it's going to copy another exclamation mark from stack into AL, then from AL into my message 1, the second location. Okay, so by using loop 2, I reversed the string back into my message from the stack. After loop 2, I use write string again to print the reverse my message on the screen so I can verify it. Let me build and run the instruction. Let's see if it's right. I have 2 write strings. Okay, the first one is before I reverse it. So before I get into L1, I call red string. So the first one is original. My message is assembly language programming is fun. The second red string is the verification of the reverse string, and you can see it's reversed. Whatever is in the end will be at the beginning of my message. Thank you for watching this video.